And now I'd like to give the floor to PhD in physics, head of neural and deep learning analysis laboratory, director for basic research of AIRI, Mikhail Burtsev, to present his intervention.
Всем привет.
Very good day. Hello, everybody. My name is Mikhail Burtsev. I'm basic research director for the AIRI, and I'm head of the Neural Systems and Deep Learning Lab at Moscow Physics and Technology University. Today I'll tell you about the recent advances, latest advances in conversational AI. Why does conversational AI constitute an important field of research today? It will become obvious if you have a look at this picture that shows you how the number of users of the top 4 messengers increased over the past several years. It is obvious that in 2015 the active messenger users number surpassed the number of users of the most 4 top social media, which means that the text communication with natural language is becoming more and more important in our everyday life. If you have a look at what has been happening at our homes, we'll make an inference that the smart house systems are advancing. There are systems that can turn on and off the light and music, and we may use a mobile device to run this smart house or smart home, and this is the normal baseline scenario, but this is not too convenient because you always have to record commands or press buttons, and it would have been much nicer if you had a chance to use your voice to give commands. So the recognition of natural language is really an important need. It's quite relevant so that the AI system can decipher what you say and can recognize what the instructions are. And today we're seeing an evident trend of obtaining personal helpers, assistants, AI assistants that have become an ultimate interface between the internet and the human being. It is our personal assistant that in the forthcoming 3 to 5 years will be widely deployed and disseminated. You may have them at the smart column or smartphone, or it may run your car or be inside your TV. It would be helpful in information search and browsing the web and social media browsing. And if we look further forward, we will see that those personal assistants will be transforming into universal helpers and assistants in the future that will be capable of doing anything, any task, and definitely will use the natural language to communicate with them. So what is conversational AI? Here, this schematic lays down the current standard approach to designing dialogue systems. We have the user who is on the left-hand side. He wants to make up his mind where to go and what to see over the weekend, and he may ask this question, and then this speech signal is converted into text, and then this text goes to the natural language understanding unit that has 3 main functions. Number 1 is domain detection, or topic detection, which is going to a cinema theater, then intent of direction. And the intent here would be to find out what is currently on in cinema. And then the entity's detection is needed to be able to further grasp and better grasp the essence of the request, which may be a genre and the date. These are the entities. So after the natural language request or query has been processed, it is transformed into a semantic frame saying that the intent is request the list of movies, and the entities are genre, which is a comedy, and date, which is the forthcoming weekend. And that goes to the next stage, to the dialogue manager. And the dialogue manager runs two functions, exercises two functions. It integrates the information on the current state of dialogue. So probably the AI may have some background knowledge, like the AI knows that the user likes drama films and sitcoms and something else, and the AI system would correlate that against the new information, and the system now is well aware of what should be done next. With help of policies, some of the actions may be conveyed. After the policy asks what movies are on over the weekend, the system would infer that the list is too long and it would take too much time to read it out, so a short list is needed. Hence, the system decides to ask what the whereabouts of the user are. So, and that intent goes to generating a natural language response, and with the help of generative models, the system just asks, where are you? And our cycle, our loop is closed, and we can maintain the dialogue, which is the conventional pattern of dialogue systems used for the past 30 years, and rule-based algorithms were used for this. And this is a rule diagram at a call center providing technical support to users. Well, practically, if the number of rules exceeds 100, the labor intensity would kinda be too high, and the rules start countering each other. Some information pieces are updated, and you have to tweak and adjust this system. So it is an inflexible approach, and the rules-based systems hence were not deployed broadly and widely, only for some narrow niche solutions. That schematic was used, and that was the case till 2015. But in 2015, a new approach emerged with respect to natural language processing and pattern building, which is the deep learning. And this diagram is the current classical natural language processing encoder plus a decoder. This is used by Google, underlying its machine translation system. So the original sequence at the input, like it's the number of characters, it is It is encoded and then decoded into the translated characters and words. And we are seeing that some information is used and the attention mechanism is employed. Those lines have different thickness parameters, so which means that there is a classification and differentiation between different types of words, and the combination of the decoder and the attention function enhances the efficiency of the machine translation or computer-aided translation, and many companies use that sort of thing, and it nearly matches a human-made translation. And now we can draw a parallel between the dialogue systems and machine translation, machine interpretation systems, and you can see parts of our dialogue system that we viewed before with an encoder that translates our input data to multidimensional space with desired properties resulting in vector representation. So we had the understanding module in the natural language to understand the input phrases. We could code any phrase, store them in memory, so memory would represent the status of dialogue, and then with the help of the attention function that coupled with the decoder helps us exercise our dialogue policy, and we will select the most important entities and intents from the memory and focus the attention, and the decoder will generate either an action or a direct response. So it seems that we can use this architecture to use and reconstruct dialogue systems, and such attempts are now being made. So this is one of the early works with neural network architecture for dialogue systems with different subsystems. It represents a subsystem for intent, another subsystem detecting the dialogue status, a unit that retrieves info from the database, and the final field that determines the dialogue policies and generating responses. If this system is trained with the real user dialogues, so versus the rule-based system, and despite like having a specific task of like booking a table at a restaurant, we can see that the neural network system requires only 4 phrases, and the modular system would require 4.5 phrases. So the neural network system is faster, and the user's choice and their preference is the neural systems. They score it 2 times as high, so the assessment is twice as high. And for more complex systems, it can hardly be scalable, because the goal and objective of maintaining a dialogue is much more difficult than translating, because in translating we maintain the sense, we keep the sense of the phrase, while in a dialogue you have to generate new senses, which is much more difficult. And it turned out that with pilot applications we inferred that a great array of data is needed, to train the system. However, of late, we have seen the new opportunities of transfer learning, which is the transfer of knowledge from the pre-trained models to a new context, and parts of dialogue systems may be designed and built without additional training, which would be the zero-shot learning practice. Let's look how it can be done. If we look, well, a pre-trained BERT model that was trained in 104 languages, and we trained it in English also to find answers to questions in a text. And let's look how it can generate the answers under the problem of booking a table. So on the left-hand side, there is a request: I'd like to make a reservation in Parisian on the 5th of March at 5:30 in the evening, it says. And there is a schematic with detailed description. The variables are given in natural language, the name of the restaurant, the number of people, the date, and the time. So we just depict and describe a data structure with natural language description, representing the information for the variable. How can we use our new model to retrieve the information for the restaurant name variable? We copy that, put a question mark. What is like saying what is the name of the restaurant? And the system finds out that the name of the restaurant is Parisian, but it was not trained with restaurant data. It wasn't trained to retrieve the names of restaurants. It just used the general capability of answering questions to extract entities. So now we ask how many people, reservation for how many people. It responds correctly. It responds correctly that it's going to be for 2 people. Then we ask about the date, and the response is the 5th of March, and the final variable is the time of booking. And we can see that the system successfully accomplished this, saying that this is 5:30. And the most important, most interesting thing is that if we take, for example, well, this was the original multi-language model. Despite we trained it in English, we can now have a go in other languages.
So you see, we have translated the query into Russian, and we say that we initially built our system for English, and we use the data, the variable description in English. And let's have a look whether, if we have a phrase in Russian, whether our system would be able to find the parts of the query that meets these or those variables. For example, so we can see that the name of the restaurant, the system copes with this task. We should not localize it. Just because we built our multi-language system and trained it in English only to answer to Wikipedia, the system can see that we want a booking for 2 and the date is the 5th of March, so it can cope with the task in the Russian language. And the opportunities, the capabilities that I am now sharing with you are just turning up, and developers are just beginning to embed them into these complex dialogue systems. And if we are building a complex dialogue system, there are parts of the dialogue where a user has to solve a specific task, but on the other hand, we would like to have a natural dialogue, as if we were talking with a human being. And for that, we need to use other approaches connected with modeling, modeling like chit-chat. So we would like to have a chit-chat approach, and other methods are used here to just carry on a dialogue, to generate cues in the dialogue. So on the left-hand side, you can see retrieval-based method, and there are cues that are prepared beforehand, and there are huge databases with hundreds of thousands of cues, and we build systems that can predict what cue should be next, and we just make a search along this database and we retrieve the cue and show it to the user. So we show the most likely cue for this context of the dialogue. On the other hand, we are restricted here by the ability to use the cues that have been prepared beforehand, and we would like to have a more flexible system. That is why we also resort to the generation-based method, where we can generate the answer proceeding from the history of the dialogue that we have. The answers here are more various, but there is a risk that we can generate an answer that will not suit the dialogue very well. Therefore, we need to filter out the answers so that they can meet and suit the tasks of the dialogue. And the leading companies are competing in who will get closer to the human being in generating this kind of cues. And here you can see how Google is building its Mina chatbot, trying to catch up with the human being. And Mina, as we can see, by growth of size, Mina is getting closer, and there is a special algorithm to change the structure of the model. So it's getting closer to the human, but still the human is still unattainable. And we can see that there is this measurement SSA that shows the preference of a human to this or that cue that a human can voice in a dialogue, or that is generated by the chatbot. Facebook is not standing still, and their chatbot is called BlenderBot. As compared to Mina, if we take a large model of BlenderBot, we will see that people prefer it in the majority of cases. So in 70% of cases, they prefer answers generated by BlenderBot to the one generated by Mina. And if we have a look at these cycles here, the BlenderBot is compared to the human. For the largest model, the model is comparable with the human being. So it is a good result. Okay. Now that we have learned the technologies and principles of dialogue systems building, let us have a look at how these complex dialogue systems are used in practice, in production. The most typical example of a chatbot will be a Limi assist system that helps shoppers order something at AliExpress. And we can see several components that look like those of our modular system. That is intention recognition, so some assistant that helps to recommend some goods or services. There is customer support, and there is a chatting service. And in rectangulars, you can see the components that are trainable, and the business logic follows certain rules. So that is a hybrid approach to building this kind of system. And we can see out of this scheme that different tasks that turn up in communication with the user are solved by different components of the system. And the system is hybrid, as it is composed of trainable and untrainable parts. The brightest example of a complex dialogue system is the so-called social bots, like Alisa from Yandex or Joy from Sber, where you can see a virtual friend that you can talk to. And the brightest example is Xiao Lai from Microsoft Research, Chinese bot, and it has 660 million users worldwide, and it has been rolled out in many countries, in many platforms, and it has very good dialogues. And if we have a look at the diagram of this chatbot, we will see that it has a lot of different subsystems, each of which is implementing various skills needed for dialogue, and they are broken down into emotional and rational skills, because in social friendly dialogue what is needed is something connected with emotions and empathy. There are a lot of skills connected with moods, with some personal events, some social scenarios, but there are also rational skills that help cope with certain challenges and problems, to buy something, to set an alarm, to find something, and so on. And interestingly, this system can generate jokes out of images. You can send an image to it, and for example, with this pizza tower, it will tell you, should I help you support it? Or, for example, if it receives an image with this bruise on a leg, it will say, it harms so bad, does it hurt? So it tries to feel sorry with the person. And if we have a look at the dialogue of this system, we will see that there are a lot of skills that are interchanged. So first there is a chatting, then Q&A, then chatting, then image search, then recommendation, and again Q&A, and again chat. And this system can be built in such a manner that it would predict the mood of a person, and predicting the reaction of a user to this or that cue, it can get the dialogue into a more positive mood. So on the left-hand side, we can see that the dialogue started in some sad mood, and gradually the system took it to a positive tune. Summing up the trends that currently exist in conversational AI, we can say that this research area of AI is developing rapidly, and deep learning is revolutionizing this area, and the current industrial solutions are based on rules and machine learning, on deep neural networks, so they are hybrid solutions. What also turns up is multi-skill dialogue agents, language models, and there are a lot of data sets, but still these systems do not have common sense that we truly need to add. Now let us have a look at the future. What is going to happen in this field in the near future? Let us start with this picture. That is a chart of the total skills that popular conversational assistants have. You can see that over 70,000 skills belong to Amazon Alexa, and it shows us that professional assistants are built not by separate companies, but by ecosystems of companies that develop skills, and the intelligence of these smart agents are not within one algorithm, but within combination of various skills. And it reflects the theory that our mind of a human being, is a community of cognitive agents. Likewise, we see here, to develop technology here, we do not stand still, and in our physical and technical lab we launched a project. Veterans might remember this picture of starting MS-DOS, and we are doing something similar that is analogous, and we have called it Deep Pavlov, and it helps us build a system of orchestration of different conversational skills of different agents, and come up with an open source system like Linux. So our approach is composed of several parts. Deep Pavlov library that has a lot of components that help us create conversational skills, and then Deep Pavlov agent helps us turn specific conversational agents out of it. And we have tested this system at the next Deep Prize, where with the help of Deep Pavlov and Deep Pavlov agent, we came up with a complex dialogue agent that could run a conversation with users through a speaker. And this diagram shows that our framework is modular and well scalable. It is run in the cloud, and we can build scalable industrial solutions on this basis. And it is actually the only open source solution that helps bridge several levels of technology stacks. That is skill management, skills themselves, NLP frameworks, aimed at understanding a natural language. So we hope that our approach will help grow faster and create smarter dialogue agents, and we also hope that you all will contribute to our further enhancement of our life, to make it more efficient, lighter, more convenient, using complex dialogue conversational agents.